All right. Well, it is 11 o'clock, so we're going to jump in and get started here. So good morning, and thank you for joining us for our webinar today on Pavement Rehabilitation and Design Goals. So just a few housekeeping items that we'd like to cover with everybody today before we jump into the content. We do have a PDH certificate available, so if you are interested in a PDH for the session today, you can download that right from the GoToMeeting or GoToWebinar here today. So look for that piece of paper in your little taskbar, and it is a PDF that you can download. We are going to have a series of 4 poll questions today as well, and so we do hope that you will participate in those poll questions. They will pop up on your screen. We'll give you a little bit of time to answer them, and then we will run through the results of those questions. So you do have the ability to submit questions throughout the session today. So with the little question bubble, go ahead and submit questions. We do have somebody monitoring those questions, and we will make sure that we answer all questions and answers at the end of the session today. And lastly, we are recording this session, so a recording will be available for you. So if you're not able to stay on for the entire session today, or if you would like to share it with somebody within your company, you're welcome to do that as well. All right, so we do have 3 presenters today. I am Elise Schmidt, and I am the general manager of our pavement division, and I have been with Benchmark for 16 years, and I am located out of our office in Waukesha, Wisconsin. Troy Kaiser is our other presenter today, or one of our other presenters today, and Troy's actually been in the industry for 35 years, has lots of knowledge, and he is a senior consultant with Benchmark, and he is also located in our Waukesha, Wisconsin. And then we have Ben Fiedler helping us today. He's been with Benchmark for 5 years. Ben is a roof staff consultant and also is handling all of the IT aspects of our webinar today. And so we're very thankful to have Ben's participation in the webinar today as well. So who is Benchmark? So Benchmark Inc. is a national roof and pavement consulting firm. We provide companies across North America with objective and technically sound consulting services to help them reduce risk, prioritize budget, and maximize the service life of their roof and pavements. So just a little bit about Benchmark. We were established in 1983. We are independently and privately owned. The services that we provide include evaluation or assessments, design bid, construction phase services, and program management, both for roof and pavement assets. We have 2 offices located in Cedar Rapids, Iowa. That's our headquarter office and where most of our roof division is headquartered. And then we have our office in Waukesha, Wisconsin, where Troy and I are, which is the pavement division headquarters. We do have 21 satellite locations throughout the United States and currently have 114 team members. So on the map here, you'll see this is actually project locations, a quick profile for you to show projects that our team has completed over the last couple of years throughout the United States. The projects in yellow are our roof projects, and projects in green are our pavement projects. So as you can see from this map, we do work coast to coast. So just wanted to give everybody a little bit of insight into our coverage area. So this is the last webinar of our series, this series that we've been doing. And so just wanted to recap the past webinars in case you missed those or didn't get a chance to attend and would like information. So we do have a webinar that was done on roof evaluation, where we highlighted the importance of reducing costs, extending the asset life, and managing risk throughout the planning and evaluation process. We also did a webinar on project interruption and highlighted risks or things that you might want to take into account due to the current pandemic with COVID-19. A couple weeks ago, Troy and I did a webinar for you on pavement management. So we discussed 3 strategies to help manage your pavement assets cost effectively. And then last week, the team covered roof design. And so they talked about critical steps to long-term roof performance. So you'll see here on the screen, Eric Hazelbush's contact information. If you'd like a copy of a past webinar and didn't receive it, please feel free to reach out to Eric. You can also submit a question in the chat field or in the question field today, and Ben will take care of that and we'll follow up with the necessary information after the session today. Okay, so what are we going to talk about today? Our webinar today, as I said before, is on pavement rehabilitation and design goals. And so the objectives of today's webinar are to provide you with an overview of common pavement rehabilitation design goals. So what should you as the owner be taking into account when you're working on designing a project? We're going to identify the appropriate maintenance and remediation methods and the timing for each. And then Troy is actually going to share with you today 2 project case studies where we're going to highlight the right method at the right time. And so we have on the screen here a quote, and Paul Schmidt is actually the founder of our pavement division. And with each and every project, he liked to say that we're blending the science of engineering with the art of construction. So we're going to jump into the content for today. So the first thing we're going to talk about is goals. So we're going to talk about goals with you as the owner and goals for your designer. So as I referenced designer today, your designer could be your in-house design team. It could be an engineering firm, could be a consultant that you use, could be a contractor if you're not using, if the contractor is designing the project. So when we talk about designer today, we're talking about the designer of record, the person that's working on putting together that scope of work for you. So we're going to kick it off with a poll question today. And that first poll question is, who provides pavement design services for your site? So I'm going to pass it over to Ben, and he's going to run this question for us.
All righty, the poll is launched, and Elise just read you the question, and the answers are contractor, engineer, consultant, in-house design team, or a combination of the above. And one quick note I wanted to make is it appears there was an issue with the PDH certificate. I went ahead and re-uploaded that, so you should be able to download that certificate now. If you do have any other future issues with that, please feel free to submit a question, and I will make sure to email it to you separately. And as we allow this poll question to get answered, Elise, I wanted to ask you, did you have any personal goals during the COVID-19 pandemic?
Well, that's a lot of pressure, Ben. But you know what I did? I did have a couple of goals to be more intentional with some of the free time that I had. And for those that know me, I have never been a runner. Always wanted to be, but never had been. And so I did set out a goal to complete a 5K during the pandemic. And I have actually completed 2 5Ks, one 2 weeks ago and one last weekend. So that was a lot of fun to spend some time outside, hitting the pavements in a different way than maybe what I do every day here at work. So yes, I did have a goal during all of this.
Very nice and good job. Definitely can run further than I can.
I will say I didn't think I could do it. So Ben, if you're up for the challenge, we could do one together.
We'll think about that.
Okay.
And it looks like all the answers are in, so I'm going to go ahead and close the poll and share the results. 3% voted that their contractor does their design services. 38% said that an engineer or consultant, 7% said an in-house design team, and 52% said a combination of the above.
Awesome. Well, thank you for sharing those results. And you know, we were curious. We figured we see a lot of companies that we work with that have a combination of the above, utilizing a contractor for some projects, maybe a design engineering firm for others, and then also many of our clients have in-house design teams. So we appreciate you taking the time to complete that poll question. So when it comes to goals, the first set of goals we're going to talk about is you as the owner. What kind of goals should you have for your pavement rehabilitation project? So first and foremost, it's very important that your goals are also the designer's goals. So any of those disciplines that we talked about, the contractor, engineering or consulting firm, your designers in-house, all of those people should be aligned with your goals as the owner. And so when it comes to the goals, what are some of the things that you should take into account? Well, first and foremost, pavement improvements and site safety. Certainly if you're going to spend money on your pavements, you want to make sure that you're improving the correct pavement and that any safety issues are taken care of. You also want to make sure that the project is done cost effectively, that you're looking at scoping the project within your budget. And when we say cost effectively, We also have down there staying within budget, but you also need to know what your budget is. And so it is really important to know that budget, to be able to stay within the budget, and to also design the project cost effectively. And you also want to take into account appropriate design use. So talking about the traffic type, we talked about that a little bit a couple of weeks ago in our webinar, but just knowing the flow of the traffic, knowing what kind of traffic hits certain areas, so that you can make sure that if you've got bus traffic, truck traffic, garbage dumpster or garbage truck traffic, that you're taking that into account. And then it's also super critical that you're maintaining facility operations during your project. And so, you know, a couple of the clients that we work with, their number one goal is to get product out the door. They're manufacturing a product that they need to get that product out the door. And so it might be nice to phase the project in one phase because the contractor can come in and get it done quickly. But in a lot of those cases, we have to phase it in 3, 4, 5 phases so that we can keep the facility operational. Complying with ADA regulations, it's super important anytime you're spending money on rehabbing your pavements, that anything you're doing is, anything that's currently compliant is put back in compliant, and then anything that is not compliant is put back within those ADA regulations. We talked about the importance of staying within budget, and obviously you want to maximize the service life, get the longest asset life out of that pavement as you can. So we've got just a couple of images here to kind of highlight some of the things we talked about. The image here on the left with the numbers on it, that's actually a copy of an as-built. So that would show project staying within budget. This project was estimated or bid at just under 1.1 million, and it came in at 984,000, I think. The numbers are pretty small there on the screen. The image on the bottom right, the color-coded image, that shows a sample phasing plan. So in this particular case, this project needed to be phased in 5 different phases, both for constructability, but also to make sure that we could maintain operations at the site as well. The photo on the top of the brand new concrete, that was actually an asphalt roadway that we opted to put back, or our client opted to put back in concrete based on the traffic usage that it saw. And then some of the other photos just show the ADA compliance as well as traffic control, and then obviously taking care of any safety issues around that drainage structure. So we talked about the owner goals, but what are some of the goals that your designer should also have? So the designer should have some of the following goals. No change orders. We all want no change orders on our project. Nobody wants to spend extra money. So making sure that they're building in any necessary contingencies, that they've taken into account all of the necessary items that might need to be included within the bid. We want accurate bid documents. So, or you as the owner want accurate bid documents. And so making sure that that accuracy is definitely key. And it's really critical that the designer include necessary quality assurance and quality control guidelines. You want to make sure as much information as possible is included up front in your bid documents so that there's no question for the contractor when they're bidding that job what is required, and that they can build those costs in. If that information in terms of the quality control and quality assurance was missing, it could result in a change order, which we just talked about. No one wants any change orders on their projects. And so including all of that upfront information in the bid documents is very critical to making sure that the contractor fully does understand the expectations of the project. And the designer wants to take into account site optimization. So what could site optimization include? Site optimization could include kind of reanalyzing the traffic flow. It could include the site layout, looking at different options to lay the site out better. This is where we kind of talk about outside of the box thinking. In some cases, the person coming in to design the project for you may not be familiar with the operations, so there should be good communication and questions and answers between you and the designer. It's also good to look at what are we planning in the next 3 to 5 years, even 10 years? Is there going to be an expansion at your facility that could impact the pavement? You want to take all of that into account, because the last thing you want to do is build a brand new pavement and then find out 2 years later that you're expanding and now you have to tear up that new pavement. This is also where you may want to look at return on investment. You know, one of the examples that I want to share with you today is a project that we were involved in a couple of years ago, where the client was actually spending quite a bit of time and money trucking stuff off site because they didn't have enough trailer storage on site. And so working together with them to try to identify some of their pain points and problems, and they worked on this return on investment, they're actually saving a substantial amount of money because they were able to expand an existing area on site so that they now don't have to truck off site anymore. So those are all things that should be taken into account in the site optimization phase. And then constructability. You want your design package to be accurate, but you also want to make sure that it's constructible. You want to make sure that the design that's put out, that contractors can actually build it. If the contractors can't build it, one, the cost is going to go way up, and two, you're going to see change orders. So you definitely want to make sure that it's constructible. And then we talked about good communication between all parties involved. And those parties could include you as the owner, your designer, maybe any subcontractors, your geotechnical companies, anybody like that, making sure that all of those parties know the intended goals and for a successful project.
At least it's really important too to include any shipping or production managers in the design phase. Make sure that they give their input so we know we're meeting their needs as well with the completed project.
Absolutely, that's a great point, Troy. All right, so we've talked about your goals as an owner and then the goals that your designer should have. So now what I'm going to highlight for you is general pavement deterioration. We're going to, at a very high level, run through conditions and what types of methods and rehabilitation might be warranted based on those conditions. And then Troy is going to share with you a couple of case studies. So a quote here from the Asphalt Pacer Manual: "The rate at which pavement deteriorates depends on its environment, traffic loading conditions, original construction quality, original material quality, and interim maintenance and procedures." So there's an awful lot that goes into maintaining that pavement and making sure that you're getting the best pavement possible. You could have a rock star design and bid package put together, but if that project, it talks about here original construction quality, if that project isn't built per the specifications and to the proper quality, you're not going to get the necessary life expectancy.
At least some people might not know what PACER is. Can you explain what the PACER manual is?
Sure. I actually do have a copy of it here. So this is our internal copy that we use. So PACER stands for Pavement Surface Evaluation Rating, and it was actually developed by the University of Wisconsin. It's something that was really put together for municipalities and cities to use, and we have adapted it over the years. We use it in-house as our rating system, and they do have PACER manuals for asphalt, concrete, gravel. They actually have it for like brick and block, drainage, and seal coatings. There are definitely different versions out there based on what the need might be. All right, so existing conditions. So when we talk about a PACER rating is anywhere from a 0 to a 10. And as Troy and I were putting together the content for this presentation, I told Troy, I don't know if I've ever seen a 0. And he said, I don't know if I've ever seen a 10. So while the rating system is 0 to 10, we probably don't see the lowest of the low or the highest of the high. So the four kind of main buckets, we've broken these into 4 buckets for you today. And the first one would be that excellent to very good category. That's where you're going to see very little to no maintenance needed on those pavements. They're in pretty good shape. The next category is going to be the good to above average. So that's where preventive maintenance may be necessary to maintain that current condition and or maybe even increase the condition of the pavement just a little bit. And then the third is our fair to below average. And this is the category where, based on the conditions, structural improvements are probably warranted. And in most cases, you may hear us refer to those as a structural overlay. And then we have that fourth category, which is poor to failed. And those would be pavements where you would be required to do some sort of partial or full depth rehabilitation. So we're going to run through each of these categories at a very high level here for you. Before we do that, we do have a copy of the typical deterioration curve in here. We included this just to kind of show you on the right-hand side. It's got those 4 main categories that we talked about. And then you'll see here, this would be without proper maintenance. Kind of the typical life expectancy would be about 12 years. And we say about or estimated at 12 years because that would really vary based on the climate in which you're in, the freeze-thaw cycles you may see. But if you're not maintaining those pavements, you're probably not going to get much more than, that 10 to 15 year range.
Like you mentioned before, Elise, if the design isn't followed or you have an improper design or poor construction, it's going to make that 12 years less as well.
Absolutely. All right, so that first category that we talked about was the very good to above average. And this would be where we would see preventive maintenance projects that need to be done. So that would, we talk about the right scope at the right time. And so that would be for the pavements that are in very good to above average. Maintenance is the type you would want to do. What kind of maintenance would you potentially consider? Well, your maintenance could include anything from your typical crack sealing to joint sealing, would include some asphalt and concrete pavement restorations, concrete curb and gutter, drainage improvements. There are times where you may be seeing some drainage issues with the original pavement, and so maybe you need to install some under drain or repair some existing structures. In some cases, a surface treatment is seen as preventive maintenance, not on all pavements, certain candidates, and then pavement marking, making sure that you are freshening up any faded markings is considered a maintenance item. And so we do have a couple of pictures here on the screen for you. The bottom picture is of some crack sealing taking place. The top right picture is of patching being done. And then you'll see the seal coating there in the middle. All right, so the next category is the category of pavements that would be in fair to below average condition. And these are pavements where a structural overlay may make sense. So these are going to be pavements where you're seeing moderate to severe defects and the service life could be extended by adding asphalt to improve the overall structural support of that pavement. So what would a typical asphalt overlay project look like? Well, the depths are going to vary for all of these. The typical kind of project would consist of milling. In most cases, it's going to be perimeter or wedge grind milling. And in some cases, it might be milling off part of the entire surface. It just depends on the site restrictions or requirements needed. And then base patching of the deteriorated areas. And then that would be followed by installing the leveling course, paving fabric, and then asphalt surface course, and lastly, your pavement markings. So the next category is going to be your your poor to failed pavements. And so where would a partial depth reconstruction be warranted, or why would a partial depth reconstruction be warranted? Well, a partial depth reconstruction is going to be best on pavements that have severe defects, but are showing slight to moderate signs of surface deformation. And so when we're seeing only slight to moderate surface deformations, those are going to be pavements where the sub base is probably okay, and we don't have to go down to the sub base. So we can just, in these particular projects, we would look to remove the entire depth of your pavement, whether it's asphalt or concrete. So remove that entire depth of pavement, undercut any of those unstable base course areas, and then again, follow that by installing your binder course, your paving fabric, if it is included in the design, lastly with your asphalt surface, and then your pavement marking.
The asphalt deformation that Elise is talking about these are visual cues we're looking for, and that would be rutting and settling. And those are going to give you your clues that the base is either lasting or the base is soft and needs to be fully replaced, like she's going to explain now for the full depth restoration or reconstruction.
Yeah, great point, Troy. So with the full depth reconstruction, you'll see that the pavements are rated in that same category. They're poor to failed pavements. But the difference is kind of what Troy talked about. So we're going to be seeing severe defects again with that surface, severe defects with severe surface deformation, which indicates that there's some sort of insufficient structural support, and then also probably some drainage issues that are contributing to that deterioration. And so with the full depth reconstruction, a typical full depth reconstruction, you'd be removing that entire depth of pavement, again, asphalt or concrete, and you would also be removing the sub base. And so then you would undercut any of that unstable subgrades. So that's going to be any of your clays or anything that's under there before you put in your subgrade separation fabric and additional support, and then you would put your stone on top of that. So in this particular case, that sub base, we're going to be removing all of that stone and then undercutting any unstable areas, adding that stone back in, followed by the asphalt binder course, the paving fabric, and then the surface course. And so the goal with a full depth reconstruction, if that's the route that you have to go, a goal with full depth reconstruction would be that it's being built right. You know that that sub base is good. You know that you have that necessary support. So hopefully in the future, you'd be able to just come in, mill off some of that top pavement, and then repave the surface because you know that you have a structurally sound base in place.
Yeah, we call that a perpetual pavement. You have a good foundation. The foundation will always be good. And like Elise said, you can just keep replacing that surface as required.
Absolutely. So in summary today, when it comes to the design goals, so again, these goals are for you as the owner and then also whoever you're using to design your project. Design goals should include site-specific design and that your project is being designed for the intended use. And we like to say in-house, no cookie cutter approach. You may have a master specification, and that's okay. You can make adjustments to your master specification, but we would always recommend a site-specific design for each and every project. It's always important that one of the design goals should be to design within budget. And so that's really key. I know in some cases when we are given a budget, we can design to that budget. If we're not given a budget, we at least try to share with our clients what the budget might be so that they can anticipate how big or small of a project they may want to do. And then you always want to use cost-effective and proven techniques. So making sure that you're looking at the most cost-effective way to build your pavement, but also get that service life out of it. And if you do that necessary maintenance, like we talked about before, and those better pavements, you're going to be able to delay when you need to spend money on your overlays and rehabilitations. So that maintenance is definitely a critical piece. And then also, if you can perform an overlay at the right time, again, right asset, right scope, right time, if you can perform that overlay at the right time, it's going to save you 3 to 5 times the cost, because a reconstruction, we showed you those full depth and partial depth reconstruction options, those are going to cost you 3 to 5 times the cost of an overlay. So it's very critical that you get those overlays done at the right time. So we're going to jump into a second poll question here before we pass it over to Troy to share 2 case studies with you. So when it comes to pavement design, what is your site's top priority? So we've talked about a lot of goals, and a couple of these might be priorities for you, but we encourage you to pick what is your #1 priority if you had to pick that. And so Ben will share those options with you.
Yeah, and the answers or the options are safety, aesthetics, cost, pavement service life, project duration, impact to operations. And while we let people have a chance to answer that question, Troy, I heard that this last weekend you added a new member to your household. We want to talk a little bit about that.
Yes, my wife decided that since we're home so much right now with the whole COVID situation, it'd be a good time for us to get a puppy. We've always had dogs, and we do have an adult dog right now, but I love her to death, but the potty training is really taxing me right now.
Was that your goal during COVID, Troy, was to bring another member of the family in and get a puppy potty trained?
No.
So what breed of dog is she?
Mainly German Shepherd with about 1/8 of Husky in her.
Nice. Getting quite a few answers in. Give them a few more seconds for everybody to get their answers submitted. And we'll go ahead and close the poll. And the results, 18% voted safety as their highest priority, 0% said aesthetics, 14% said cost, 57% said pavement service life, and 11% said project duration and impact to operation.
Wow, great. Well, thank you for sharing those results. So it is interesting. 0% said aesthetics. So that's good to know that you're looking at the safety, the cost, the overall pavement life, and then kind of that project duration and what the impact is to your facility. So with that, we're going to hand it over to Troy, and he is going to share with you 2 different project case studies of projects here at Benchmark.
Thanks, Elise. The first project is going to be a structural overlay project that we did here in Wisconsin. And we got this nifty cross section that was put together by one of our drafting team, and it uses actual photographs to create this. That's why it looks so great. But you can see we've got our existing pavement structure, including the stone base, the binder, and the surface. It has one crack in it. And then you can see we do an asphalt leveling course, the paving grade fabric, and then the asphalt surface or overlay. So this was a light duty retail parking lot, roughly 1,700 square yards. Pacer rating was above average condition. It had to be done in 3 phases because it was right by the food court of this mall, and we couldn't shut down the whole area at one time. The total project cost was $310,000. The scope of work included curb and gutter repair, milling, base repairs, asphalt leveling course, a paving grade fabric, and the asphalt surface course. So when is an overlay appropriate? An overlay is appropriate when the existing pavement structure is adequate. How do we check that? Well, we talked about those visual clues for pavement deflection, but borings should be taken to verify. And what borings will tell us is the depth of the existing asphalt, the depth of the existing stone, and any moisture that may be in that subgrade soils. At this particular site, the existing asphalt was between 5 and 5.5 inches thick over a 7-inch crushed stone base. So it was a very good candidate for a structural overlay. We also need to make sure that existing drainage is adequate for structural overlays. You have to think about it. You're adding a certain depth of asphalt on top of what's there. We don't want to create areas where we're backing up water, where ponding will occur. A good place to use a structural asphalt overlay is when the pavement is raveled. Raveling is when the pavement starts coming apart from the top down, the fines come out, the stones start getting exposed. A structural overlay is a good way to seal that surface back up and protect that initial investment. Cracking is normally slight to moderate in severity, but usually the severe cracking is isolated, like isolated alligator areas. And the last thing would be when preventive maintenance is no longer cost effective, that's when you need to be doing those structural overlays before the pavement deteriorates to the point where a full reconstruction is your only option. So here's a photograph of the existing pavement. You can see it's in pretty decent shape. There is a area of isolated alligator cracking right by the handicap symbol. That would be one of the areas where we do what's called base restoration. We would remove that broken up asphalt and replace it with new asphalt before the overlay goes on. The curb at this site was actually in pretty good condition. Some of the bull noses were damaged from snow plowing operations. Those areas were spot repaired. Rebar was added into the curb and gutter to help it be more resistant to snowplow damage. The curbs, the islands at this site, the curbed islands were along the perimeter of the area. So we left them in at the same elevation. If you have islands that are in the center of a parking lot that you're overlaying, even if the concrete's in good condition, it makes sense to tear that out and re-pour those curbs at the higher elevation. So you maintain that thickness of the overlay over the top of the existing asphalt without having to mill down into those islands, which can also create low areas that hold water. So a real key to a successful overlay is the milling. When milling machines came along, they really revolutionized how overlays were done. In the past, contractors would thin up the asphalt at the butt joint or at the joints where you matched into your existing pavements or where the overlay ended, or they would have to actually saw cut the asphalt, remove 5 to 8 feet of the existing asphalt so that when the overlay came to that joint, it would go down in and match to the existing pavement. But then you always got a crack where that pavement was saw cut for the removal. And the milling machine, it has a round drum with teeth that will actually grind the asphalt. And what that allows you to do is that drum can be lowered for full depth removal of the asphalt, completely remove it, or it can be tilted to create a wedge grind so that where you match an existing pavement with your overlay, it creates a nice joint for that full thickness of the overlay to terminate at. So milling is a must for a quality overlay. Here's two examples of milling. The photograph on the left shows them milling the inner ring road on this project. The inner ring road was a little flatter than we needed to just do the standard overlay. So we had to mill the asphalt completely off the inner ring road. And then once we got past that first set of islands, we were able to mill out to 0 so that we'd be overlaying the existing pavement without milling it. The photograph on the left shows them milling the joint between 2 of the 3 phases. And you can see they've milled down and are wedging back up so that the pavement can be full depth at that joint. The next phase was to proof roll the existing asphalt after the milling was done. You can see here in the inner ring road, when a truck was driven over that, the existing asphalt was moving, and our designer or our consultant on site decided that needed to be repaired before the overlay went over it, because it would affect the service life of this pavement. And you can see it's marked out, and the contractor could have brought in and saw cut and removed this asphalt with an excavator and then repaved it, but because he had a mill on site and the rolling was done while the mill was still there, they opted to use the mill to remove this asphalt full depth. And here's that operation. You can see the mill on the left just came into the area, lowered down 2 inches below the existing surface. Nice thing about a mill is it mills the material right into a truck to be hauled away. It's very fast, very clean. Just the edges need to be scraped up a little bit with a shovel. And on the right side, you can see the area that's ready to receive the asphalt base patch.
Troy, how long would it take to do that type of patch with the mill? How long would it take the mill to?
I would say the mill they probably had that milled out in a matter of 10 to 15 minutes tops.
Okay.
Where with an excavator, you're probably talking an hour or better. So okay. It's quite a cost savings. Okay. Next would be the asphalt installation. Obviously, you would start out like they're doing here in the photograph. They're filling in a base patch with that 2 inches of the lower lift of asphalt. And with the asphalt, you want to make sure you have the proper mix type, the proper thickness. We want to lay that asphalt at the right temperature. We want to make sure it's compacted. And also we want to have quality control where we take samples and do material testing to make sure it meets the specifications. So next, after they did the base patch, they went to put on the leveling course. You can see they are in the photograph on the left, they're doing the leveling course in the inner ring road first. You can see they've sprayed a tack coat on there. Tack is basically a glue so the leveling course will adhere to the existing pavement. It's a mixture of asphalt, cement, and water. When you spray it down, the water evaporates, leaving that asphalt cement coat on there, which is very tacky. That's why we call it tack. And then you see in the right photograph, they're doing the leveling course over the main body of the parking lot. And the reason we do a leveling course is it fills in any deformations and gives us a nice clean surface to put our paving grade fabric on. I talked a little bit about compaction. You can see here they had nice big rollers on this project to get compaction. We had a nuclear density testing company out there. On the right, you can see he's testing the leveling course. The lower lifts of asphalt require 91% or 92% of 100% of the that's 91 or 92% of what the laboratory got, which would be considered 100% compaction. And then for the final surface, we recommend 93% compaction. Okay, after the leveling course was placed, the next was the paving grade fabric. Straight asphalt cement that's not cut with water is sprayed on top of the leveling course, and then they apply the paving grade fabric over the top of the leveling course with a tractor. You can see in the operation here, they've got a nice coat of AC, and they're placing that last roll of fabric down the drive lane. One point I wanted to make about the fabric, when you're laying the fabric, you want to make sure that the overlays are just like a roof and are overlaid so that water will always sheet off of fabric. That goes for subgrade fabrics as well that go on top of the subgrade before you place stone. Okay, once the fabric is installed, then we're ready to place the structural overlay or the asphalt surface. You can see here the crew is doing that. And once that hot asphalt goes on that fabric that draws that asphalt cement that was sprayed on top of the leveling coat up through the fabric and into the upper course of asphalt, bonding it to not only the leveling course, but also bonding it to the surface course. One thing I wanted to point out here is the crew is paving from the mall to the outer ring road. That's the direction that traffic flows. What this does is it gives you a nice smooth ride and also eliminates a joint every 12 feet or so if you would pave it the other way, which is maybe it was more convenient to pave the long way, but we require them to pave in the direction of traffic to eliminate a bumpy ride. And also, if the joints ever start to settle, the water flow would be trapped in those joints and get down in those cracks and perhaps cause premature failure. It's nice to see that the back end man on the paver has a 4-foot level out. He's constantly checking drainage to make sure that this pavement does drain properly.
And Troy, you talked about paving in the direction of traffic, and that's one of those things that should really be included either as a note on the plan, or it should be noted as a requirement in the specification document to make sure that the contractor, again, knows that expectation up front, that because as you said before, it could be easier for them to pave the other way. They have longer passes. So it's important to know that the contractor knows your expectations up front, that you want them to pave with the direction of traffic.
Absolutely. Make sure your designer includes that kind of verbiage in the spec. One note on asphalt depth. The final asphalt surface was to be 1 3/4 inches. We talked about compaction. Asphalt does compact, so we have to lay that asphalt loose at 2 1/4 inches, so that after it's compacted, we get 1 3/4 inch finished pavement. It's very good. Make sure that your designers are stating that the asphalt thicknesses are minimum thicknesses, not average thicknesses, so that you know you're getting that proper thickness throughout the project. Here's the finished surface coat. And one thing I wanted to point out here was seams and overlaps. You can see in the lower portion of the photo, the surface course doesn't come all the way out to the butt joint like the leveling course does. You always want to overlay or offset your joints from your final lift of pavement so they're not right over the top of the joints in your lower layer in the leveling course. That way, when you do eventually get a joint crack in the surface, it's not right over the top of a crack or a joint in the lower lift, and will help prevent that from getting down into your stone base. And this joint here is actually between phase 1 and phase 2, and by offsetting it there, they can mill right along that where the leveling course ends, and we'll achieve that offset over that offset joint for that pavement in that area. And here's the finished product with the striping done. Very nice looking parking lot, drains well. Owner was very happy. We were very happy, and the contractor was very happy with how it turned out. So with that, we're going to go to our next poll question, which has to do with ADA issues. You'll be asked to pick one of these photos. So I'm going to kind of explain what they are. Photo A is a public access ramp. Photo B is a boulevard crossing. Photo C is a concrete ADA parking area. And D is an asphalt ramp. And your question is, which photograph does not show an ADA violation? A, B, C, or D? And with that, I'll turn it over to Ben.
All right, give you a few more seconds to look at this slide. And one thing I did want to point out is the question is which does not show an ADA violation. We were kind of reviewing this yesterday, and as a roofing guy, I thought I was real smart and thought I picked the right answer, but turns out I didn't read the question clearly and picked the wrong one. So with that, I'm going to go ahead and launch the poll question and give you a few minutes to select the correct answer. And while we're on the topic of ADA, Troy, what's the most challenging aspect to constructing the ADA pods?
By far, Ben, the most challenging aspect of constructing ADA pods is making sure that the crews hit the grades. ADA parking stalls cannot be over 2% drainage, and it's very difficult to make sure that the contractor can hit those grades, and that always seems to be the toughest part of constructing an ADA parking pod.
Perfect. Give a few more seconds for the results to come in. The interesting thing is the answer I picked yesterday that was incorrect is actually the least answered question. So looks like I'm alone and picking the wrong answer.
Well, you are a roof guy.
I'd say it's understandable, I hope. And with that, we'll go ahead and close the poll, which I guess in this case is more of a test, but we'll go ahead and share the results. 25 voted public access ramp, 7% voted boulevard crossing, 50% voted concrete stalls, and 18% voted asphalt ramp.
Okay, thanks, Ben. We'll actually take some time to talk about the 3 photographs and explain why they were a violation. The public access ramp was way too steep. You can see it's at quite an elevation there. The sidewalk, when it was built, should have been built lower so that the ramp from the roadway to the sidewalk wasn't that steep. The boulevard crossing, the ramp is fine, but then they did not put a ramp through the boulevard section, so they're directing people in wheelchairs right to a 6-inch curb. So that's the violation there. The concrete stalls was the correct answer. There was no violations there. And I kind of wanted to point out here was we went with concrete in these stalls because concrete is much easier to meet grades with because we put forms around there. We were able to shoot the grades on the top of the forms to make sure they were correct, and then poured the concrete in the middle and strike that off with a strike plate. With asphalt, it's a lot harder to hit those grades, and what happens is they end up being either too steep or they end up being flat, and then you have water sitting in your stall, which is also a violation. And D, the asphalt ramp, 2 things here. Number 1, it's too steep, and it's also too narrow. It's a dangerous situation where someone in a wheelchair could tip over when they're using this ramp. So just wanted to explain that for everybody before we move on.
So just to recap, the correct answer was C, the concrete stalls. The other 3 options did have ADA violations.
That is correct. Okay, the last aspect of this this project we want to talk about is ADA improvements that were done. Well, we took advantage of the overlay. Here's a picture of how the stalls were. There's a curb and gutter up along that sidewalk. That's an ADA compliant sidewalk that comes from the bus stop in the background all the way up to the shopping mall. But where the people were parking in these ADA stalls, when they exited their vehicle, they had to go behind the car stalls and into the drive lane to get over to the mall. So we took advantage of this project to do this ADA improvement. I just wanted to explain a little bit about that. So the first thing we did was we removed that curb and gutter. The curb and gutter has a rounded face, which is not a good surface to try to butt into with asphalt. And we replaced it with a vertical curb with a 90-degree edge, so we had a nice edge for our pavement to go up against. Next, the gap between the curb and gutter and where the curb and gutter was and the new curb, vertical curb, we filled that with a lower lift of asphalt, just like a base patch. And then when the crew did the overlay, they matched the top of that new curb so that it matched the ADA sidewalk. And the finished product is there on the lower right. You can see now when people exit, they very safely go to that ADA accessible sidewalk that was already there and find their way to the mall. So it was a nice improvement to take care of during this overlay project that the owner really appreciated. So take advantage of those kind of things when you're doing a reconstruction or an overlay. Here's the project 6 years later. You can see it's holding up very well. It did have some cracking. I would assume this would be reflective cracking from the pavement that we overlaid coming up through, but the owner has already done some crack sealing to make sure to keep water from infiltrating that pavement. And it's a very nice looking pavement for 6 years old.
And Troy, that timing, having the crack sealing in there, that's not really a concern. That timing for that crack sealing would be probably somewhere between years 4 and 6. Is that right?
definitely, especially with an overlay. An overlay is not a brand new pavement, so you are going to get some reflective cracking. So that time frame of 4 to 6 years for doing preventative maintenance is right on track. And with that, we'll go to poll question number 4 before we go into our next sample project. What is the average thickness for reinforced concrete used in a trucking application? Ben?
All right, and the answers are 6 inches, 8 inches, 10 inches, and 12 inches. And while we give you a minute to answer this poll question, you know, at least when I was growing up, I had always wanted to work in construction. I always watched these videos that were made for kids on different things about construction. And so, what did you want to be when you were growing up?
You don't think I wanted to, like when I was growing up, I thought I'm going to work for a roof and pavement consulting company, Ben?
Well, that's actually, I think, what most of us really hoped for.
No, actually, when I was growing up, when I was little, I wanted to be a teacher. And for a couple of different reasons, I chose not to go that route post-school. But I do appreciate the opportunity to be involved in webinars like this. And I am very much a paper and pen, lots of colored pens type girl. So I did always want to be a teacher, but I think there are some things that I do today that I would do if I was a teacher. So I'm very content and happy with the career choice that I ended up with.
Well, we are definitely lucky that you joined us as our general manager. And although I do think that you do make a great teacher, especially during these webinars.
I can say I never thought I would work in the construction industry ever. So I bet my dad's happy about that though, because he's been in the construction industry his whole life. So.
Very good. And with that, we're going to go ahead and close the poll and share the answers. 7% voted 6 inches. 44% voted 8 inches, 44% also voted 10 inches, and 4% voted 12.
All righty. Well, the answer is, and this varies a little bit, but the average thickness for a concrete pavement in a trucking or heavy duty area is 8 inches. Some areas are a little bit more, some are a little bit less, but 8 would be the average. So now with that, we'll get into our next case study, a full depth concrete reconstruction. This would be exactly as an asphalt reconstruction, except for the final pavement is a little bit different, obviously. And so we got another one of our nifty cross sections here. It shows the clay subgrade. The black strip there is the subgrade separation fabric. We have an adequate stone base, and then we have our concrete pavement poured on top of that, which includes epoxy coated dowel bars for the relief joints, rebar for our connections into existing concrete pavements, a wire mesh reinforcement, and also our control relief joints are shown in this as well. So here we go for our case study. This was a heavy duty truck dock, and this was also in Wisconsin, just happened to be that way. Project size about 3,000 square yards. The pavement, as you can see, was in poor condition. We're seeing a lot of faulting. There's obviously an issue with the foundation for this concrete. It was in a loading dock area, so it had to be done in multiple phases. The construction cost was $292,000. And the scope of work for the heavy duty concrete reconstruction was remove the concrete and existing stone and subbase, install a subgrade fabric, a 9-inch crushed aggregate base course, and an 8-inch reinforced concrete pavement. So when is reconstruction appropriate? We talked about it a little bit, but when the existing pavement has deteriorated to a point where a structural overlay is no longer cost effective, reconstruction is your only option. And I want to make a point here that I forgot to make before was you can do structural asphalt overlays over concrete. We've done it and has been very successful. It just has to be the right method at the right time in the right situation. Next, the existing pavement's poor condition is affecting the facility operations, which it was doing here. They were having product damage from the trucks bouncing over this bad pavement. And if a safety hazard exists due to overall poor condition of the pavement, obviously there were trip hazards here to not only the facilities employees, but the over-the-road truckers who were getting in and out of their trucks to access the building. So the first step was demolition. You can see they used a concrete breaker on a hydraulic excavator to break the concrete into smaller pieces to make it easier to remove. Then they used a hydraulic excavator to remove the concrete pavement, the existing stone, and any of the dirt that needed to be removed to get us down to our proper subgrade. Want to make a note here, you can use a mill to remove concrete pavement. It's a little harder on the mill. It takes a little bit longer. It's more expensive because you go through more milling teeth. This project here, we can only take out 3 dock doors at a time, and it just wasn't big enough an area to justify having a mill on. So using excavation equipment was the way to go for this project. One note about the demolition, this is a photograph of a piece of the concrete that was removed. What I'd like to point out here is that the reinforcing mesh that was put in this concrete was totally inadequate for a heavy truck area. This was something that this thin gauge wire would be something you'd want to use like for a sidewalk maximum. Also, you can see the wire is at the bottom of the concrete where it needs to be in the middle of the concrete to be effective. 9 times out of the 10, this is where you will find the wire when you excavate a concrete. And what happens is when they're pouring the concrete, even if they have some kind of support to hold the mesh, the guys will walk on that mesh, it'll get pushed down to the bottom where it's totally ineffective. So we'll talk about that a little bit further in the next couple slides. Next part of the installation was they installed the subgrade separation fabric and the 9-inch stone base. And you can see here we only had 3 or 4 docks to work in front of. And when the stone was installed, we also used nuclear density testing to make sure that it was compacted to 96 to 98% compaction based on laboratory testing of that material. Next was to get ready, install the reinforcing steel in preparation for placing the concrete. You can see on the right here, they've painted lines on the stone where they had to place chairs. The chairs will support the heavy mesh wire reinforcement. And they also placed, in the photo on the right, you can see they have the dowel baskets, which hold the smooth dowel bars. And those are placed where the saw cut relief joints are. So every place we do a saw cut relief joint, there'll be a dowel bar in that area to hold those 2 slabs of concrete together.
Troy, is there anything that's epoxy coated here in this photo?
Yeah, the wire mesh you can see and the chairs that hold the wire mesh up are not epoxy coated, so they have a kind of a rusty color. But you can see the green dowel bars. They're green because they're epoxy coated. Almost all epoxy coated rebars or dowel bars have that green color. So we highly recommend epoxy coated steel because it's resistant to salt, not only in northern climates where they use it for ice control, but around coastal areas because salty sea air can also cause premature corrosion of these steel reinforcements. Okay, so next step was to install the concrete itself. You can see in the lower left, they're installing the concrete. You see they are walking on the reinforcing steel, but it has adequate chairs to make sure that that steel is in the middle of the pavement cross section. They're using a pumper truck. You can see the hose coming down where the concrete's coming out of. They did this so that they could pour it all in one phase. If they didn't have a pumping truck, they could only pour a certain distance from the dock doors there because the chutes on the cement truck can only reach so far. So this allowed them to have the whole pour done at one time. And the photograph on the right shows them sawing the relief joints as kind of the final step to the concrete installation.
And Troy, how do they know where to saw those relief joints?
When they did the layout to where to put the dowel baskets and they painted on the gravel, they put paint marks on the pavements, existing pavements, all around the outside. So then when they were done with the concrete, they were able to string line and snap lines, chalk lines on the new concrete and follow those lines with the saws. So they knew that those joints were right over the top of those dowel baskets. And the last step is the installation of the concrete joint sealer. On the left here, they're installing a backer rod The tool he's using here is making it sure it's set at a certain depth. And then for this particular application, it's industrial. We used a rubberized hot pour joint sealer, the same kind of material used for filling asphalt cracks.
But you would not want to use that if you have like retail sidewalks or something. The reason it was used here is really only because it was an industrial setting. Is that right?
Yeah, that's right. Absolutely. For sidewalks or a retail setting, you want to use like a silicone sealer that comes in tubes. It's cold, installed cold, and it's got a gray finish. It looks more like the concrete, just a nicer look. This has a black finish, obviously, but for an industrial site, it didn't matter, and it's a good product. And the last thing for this particular project was when the concrete was installed, at the time it was installed, it was tested for air and slump. And at the time, cylinders were taken right off the trucks that came to the site. Those cylinders were stored here for pickup later by the testing company. And they did brakes on those cylinders in the laboratory to make sure that the concrete met the strength that we required. And here's that safe pavement 5 years later. You can see it's holding up very well. And in summary, for the two projects, the keys were proper preparation, detailed investigation, a good design, a pre-construction meeting to make sure that a lot of the preliminaries were talked about so that the project went smoothly. There was an inspection and construction oversight to make sure that the materials were what was specified. There was quality control to make sure that the rebar was put at the right elevation. There was cost tracking and some value engineering done. And the last thing was quality assurance. Materials were sampled and sent out for testing, and compaction testing was done. And those were the keys to making these successful overlay and reconstruction projects. And with that, we'll see if Ben has any questions that came in for us.
Yep, and real quick, I do want to just real quick state we are recording this webinar session. I realize that we are at the end of the hour, so we will be sending the recording out to everybody that attended, so that if you do need to jump off right now, you will be able to view the questions at a later date. However, we did get quite a few great questions in. It's very apparent that we have a lot of people on here that know more about paving than I do. So we will start off with this question, and they're asking, is there an alternative to using paving fabrics for both structural overlays and FDR? Troy, do you want to touch on that a little bit?
An alternative to paving fabric. The reason we put the paving fabric between the layers of asphalt is it creates a barrier in the future when a crack appears in the surface, so that when water goes through that upper layer of asphalt, there's that fabric as a barrier to keep that from getting down into the lower lifts, softening up the stone and creating a premature failure. I don't know if there's really an alternative to pavement fabric. There's pavement grids that add strength that are placed between lifts of pavement, but they're not a solid product where it would create that barrier. So if you're going to go with a grid in the pavement to increase strength, I would still go with the solid fabric to create that water barrier.
Very good.
The question was subgrade fabrics. Is that right, Ben? Well, let's just assume it was, and I'll talk about fabric. The fabric we showed was a subgrade separation fabric. Its main job is to separate the stone from the dirt subgrade and keep them from intermixing. It does add a little bit of strength, but we don't use it as a strength factor. There are geogrids that you can put on top of the fabric after that's installed that do add strength to your pavement cross section by locking the stone base a little bit tighter. So there are some other tools we have in our toolbox of design for creating pavements that are going to last a long time. I hope that answered their question.
Perfect. The next question, is there a rule of thumb for compaction depth? 2 1/4 compacts to a ½ inch to 1 3/4 inch. Is that standard?
For that depth, it is. Obviously, the thicker the asphalt, that you're looking for, the thicker it needs to be placed loose to get that final compaction. The problem is, if the layers get too thick, you won't achieve compaction. We don't like to see pavements compacted that are over 3. We don't like to construct pavements that are over 3 inches, and normally we make those our lower lifts. For upper lifts, I don't like to see upper lifts placed more than 2.5 inches thick, just because you don't get the compaction.
All right. And the last question we have, when and do you recommend routing when doing crack sealing?
The purpose for routing when you do crack sealing is to create a reservoir for the asphalt, the hot mix sealer to go into, so that as the pavement expands and contracts, there's enough material in there to expand and contract with it. If you just drizzle that material into a crack without routing it, when the pavement expands, it pulls away from one side or the other, just letting water get in. I think any crack that's less than 1/4 inch, you should probably route those, make sure that you get that reservoir. If they're larger cracks, they've already got a reservoir there, but you may have to add backer rod in the bottom to make sure your filler doesn't just keep disappearing down into depending on how deep the crack is. So I think anything less than 1/4 inch, you want to route to make sure you get a good reservoir.
Very good. And with that, that is the end of our questions that we have available to us right now. One thing I do want to point out is at the conclusion of this webinar, you will be prompted with a survey. We wouldn't mind if you wouldn't mind, please fill that out and give us your feedback on how we did today.
Thanks, everybody.
All right, thank you so much. We are glad that you guys joined us, and have a great Memorial Day weekend. Bye-bye.